Hey. In the last video I said that our implementation of keyboard split, or key ranges, is not complete until a possibility exists to transpose notes up or down. Such a capability is useful, anyway. For instance, consider a scenario when you learn to play a song in one particular key, but when teaming up with other musicians, they want you to play it in a different key. Unless you are an experienced musician, it might be challenging to do it at the drop of a hat, but when you are able to simply change the pitch of notes on your piano, you can still play the song as you learned it. So today, we are going to write code to shift the pitch of notes on the piano, and also do something called pitch offset. With pitch offset, the pitch can be changed in tiny amounts to introduce special effects in combination with layering sounds. Let's begin with the user interface. On the channel user control, I added two new fields, one for pitch shift and one for pitch offset. These are read-only text boxes. They respond to two user actions, pressing down a key on the computer keyboard, and rotating the mouse wheel. As the result of these actions, the pitch value will change. The two additional event handlers will change the appearance of these input fields, depending whether they have the focus, or not. Now, let us see how these events are handled. Well, one thing is pretty clear from the code here, the numbers in the input fields increment, or decrement. Either when the arrow keys on the computer keyboard are pressed, or the mouse wheel is turned. And then, there is this change parameter value function here. It looks rather obscure, doesn't it? Let me explain. To update a setting in the internal memory of a MIDI device is quite an expensive operation. I mean, expensive in the amount of processing involved. Do we really want to do it on every single key press? The user might want to change a value from 0 to 24. That means 24 key presses, of which only one is really significant. So, what I did here is to introduce a slight delay, and only update the setting on the device when the user stopped pressing the keys. Up here, I declared a timer variable, and a flag which indicates whether the editing is still in progress, or the user has stopped pressing the keys, or turning the mouse wheel. The timer is created and initialized here. The timer's tick event fires half the second after the timer has been started. The event handler for the tick event is this, and this is where the actual update of the setting occurs. But let's just go through this in chronological order. When an up or down arrow key is pressed, the value in the text box is updated. Then, we enter the change parameter value function. The argument is a reference to the text box control, where the event occurred. If the user edit is already in progress, we simply ignore the key press. Nothing is changed on the MIDI device. Otherwise, the timer is started. When the half a second delay elapses, this event handler gets called. Here the timer is stopped, and the program statements relevant to the control of interest get executed. So for pitch shift, ignore these lines for the moment and just concentrate on this line. The set pitch shift function on the device gets called, with the channel number and the new pitch shift value as arguments. The set pitch shift function is similar to the key range function we looked at in the last tutorial. In fact, it is almost the same. We are using the same memory buffer here. I need not say more on this. The address, and other details, can be found in the MIDI implementation document. But what if your piano does not implement, or respond to the system-exclusive MIDI message? Not to worry. We can do a custom implementation of pitch shift. In the program I created a channel pitch shift static class, with an array of pitch shift values, one for each channel. When the pitch shift value is changed on the user interface, the new value is stored in this array. If the MIDI device is not a Roland, or not a Roland compatible device, then nothing happens here. The pitch shift change occurs elsewhere. If you followed the previous tutorial, you would probably have an educated guess as to where the change takes place. Yes, it is in the MIDI in message handler callback function. Here it is. The pitch of the note is changed by either adding to, or deducting from, the original value. Let's see if it works. It does work. Fantastic. Implementing pitch offset is similar, except I don't have a custom implementation, only what Roland provides. The tricky thing here is, that the values are stored as nibbles, instead of bytes. In the setPitchOffset method I have a function, which converts a byte to nibbles. So, there you have it. We can now split the keyboard into sections with a different sound on each, and transpose notes. These can be really useful in practice. In the next video I plan to explore a new and exciting topic. Namely, special effects. Things like flanger, delay, distortion, rotary effect, and so on. See you then.